Okay, students, let's move on to the next hybridization concept, sp3 dehybridization. Sorry, look at sp3 hybridization. So, what happened in the sp3 hybridization here? You can see very clearly what happened in the sp3 hybridization: one s orbital, three p orbital, one d orbital involved in hybridization. They form a sp3d hybrid molecule. So, remember the one s orbital, three p, no, total number of five sp3d hybrid orbital will form. Solely. But you know very well the hybrid orbital must containing of the equal amount of energy. You can say clearly if any atom having the vacant d orbital or single unpaired electrons or single paired electrons or d orbital, they will undergo sp3d hybridization concept only. You see very clearly what happened in the PCl5 molecule, formation of PCl5 molecule. I'm just taking here the, you see very clear phosphorus having the electronic configuration of phosphorus is 3s2, 3s2, 3p3, 3d0. So what happened there? Phosphorus here forming 5 bonds, but here only here the only 3 electrons available for the bond formation. What about the remaining 2 electrons? The electron which is present in the s orbital, it move from the s orbital to d orbital only. This is called excitation. After excitation, what happened there? The electrons are they creates a unpaired electron. You can see clearly. So what when under excitation, the electron move from 3s orbital, 3d orbital. There is availability of the 5d orbital. There is availability of the 5d orbital. These 5d orbital, each orbital, so this not d orbital, each 5 orbital, one s orbital, 3p orbital, one d orbital. They form a 5 hybrid orbital. This 5 hybrid orbital involved in the bond formation, they form a 5 bond. In that 5 bond, what happened there? 2 bonds in the, okay, 2 bonds in the, what happened there, in the equatorial position. 2 bonds in the equatorial position with the bond angle is 120 degrees only. Rest of 2 bonds are the axial position, the bond angle with the 90 degrees will come. Rest of the what happened there? Rest of the elements are in the, okay, rest will be in the equatorial position with bond angles 90 degrees will come only. So what happened in this case? What happened? Remember is then in this case sp3 orbital. You have doubt will come. So which orbital involved in the bond formation? First z orbital involved in the bond formation. Sorry. First z orbital involved in the bond formation. Sorry. Students, you get very clear idea what happened there. The one s orbital, 3p orbital combined, they form a sp3 hybrid orbital only. You see very clearly 3 atoms are in the one plane, 2 atoms are in the above the plane and below the plane only. The bond angle just take it when the atoms are 120 degrees or bond angle will come. Here bond angle is 90 degrees will come only. So what happened there? This is called axial bond angle is 90 degrees. Equatorial bond angle is 120 degrees will come only. Okay. Next one is hybridization. You can SP this called as a sp3d hybridization only. You can see clear this another, but the molecular structure of the p sulfide phosphorus pentachloride molecular structure will be like this. Next, move on to the hybridization concept is sp3d2 only. sp3d2. What is sp3d2? Remember, you can see clearly one here also one s orbital in the process, one s orbital, 3p orbital, 2d orbital involved in hybridization. They form a sp3d2 hybrid orbital only. sp3d2 hybrid orbital. You can see very clear what happened there. Here the suppose s sulfur electronic configuration is 3s2, 3p4. So what happened here? Here 2 electrons in the p orbital also is there. Here single paired electrons. Here also one more electron is there. In the first excitation, the electron which is present in the p orbital, it move from the d orbital. Move to d orbital. So what once again say, no, in the first excitation of the first electron undergo lower energy level to higher energy level. So what happened in this case? What happened? The electron move from the orbital of 3p to orbital of 3d. In second excited state, what happened there? One more x electron, it moved from the s orbital to p orbital. Resulting what happened? It creates a 1, 2, 3, 4, 5, 6. 6 orbital is created. This 6 orbital involved in the bond formation. So it is called as a 6 sp3d2 hybrid orbital. 6 sp3d2 hybrid orbital. So what happened there? What happened in this hybrid orbital forms? No, here what happened there? Along with overlapping, along with p2 pz orbital, some other d orbitals also involved. Some other d orbitals, but dx square minus y square orbitals also involved in the bond formation. and see the structure is called as the octahedral structure. The bond angle will come as 90 degrees only. The structure is called as a octahedral structure. The bond angle will come as 90 degrees only. If you see sulfur molecule is there, sulfur molecule, 4 atoms in the one plane, 2 atoms in the above the plane and below the plane. 4 atoms in the one plane, 2 atoms in the above the plane and below the plane only. If you see the important points, the number of sigma bonds are 6 will come. There is no possibility of pi bonds. Octahedral structure. Octahedral structure. This is nothing but a sp3d2 hybridization only. sp3d2 hybridization. Next, one more hybridization is called as a sp3d2 hybridization. Okay, hybridization and structure of the molecules only. You see very clearly what happened here. Consider the number of hybrid orbitals involved. Number of hybrid orbitals, hybridization equal to sum of the bond pair plus sum of the lone pairs only. Hybridization is sum of the bond pair, By using the short trick, we can able to find the hybridization of the individual molecule. Suppose you can say the only one bond pair, 2 bond pairs are there. This hybridization is sp hybridization. 3 bond pairs are there. Hybridization is sp2 hybridization. 4 will be there. It's called as a sp3 hybridization or dsp2. 5 will be there, sp3d dsp2. 6 will be there, sp3d2 or d2 sp3. 7 will be there, sp3d3 d3 sp3. This is nothing but types of hybrid orbital. If you see the hybridization is sp2 hybridization, bond pairs are 2, lone pair is 1. You can see that is called a bent molecule will come, V-shaped molecule will come on. V-shaped molecule will come on. So what I mean to say is that here the lone pair of electrons also will decide the shape of the molecule. If you see the hybridization, sp3 hybridization, bond pair is 3, lone pair is 1, bond angle is 107 degrees, so like ammonia molecule. The shape will be the pyramidal shape. And you can see the sp3 hybridization, 2 bond pair, 2 lone pair, bond angle is 104 degrees 5 minutes. What happened there is V shape is there, is also water molecule shape. Very well is then ammonia also having the pyramidal sp3 hybridization, water molecule also sp3 hybridization, methane molecule also sp3 hybridization. Because of the lone pair of electron, there the bond angle will be very solid. This is a basic idea regarding the hybridization concept. This is nothing but a basic idea regarding the hybridization concept only.